And we're live.
Hello, everyone. Thanks for joining us today. My name is Heidi Cullen, and I am the Chief Scientist at Climate Central here in Princeton. And we are just really excited to have our third Google Hangout with folks. And this third hangout actually comes at a pretty auspicious moment, as world leaders are gathered in Paris to talk about reaching an agreement around climate change, bringing 190 plus nations together to agree on action around climate change. Dealing also with the hottest year on record. In fact, I think we've got a graphic here that shows you that right now 2015 is pretty much it's locked in. The 2015 is going to be the hottest year on record, and as you see in this plot here, gosh, 2015 is really just head and shoulders above all of the previous warmest years on record. So, 2015 itself is a pretty auspicious year when it comes to global temperatures. And I'll say that for those of you who think in Celsius, this is actually the first year that we've gone above this 1 degree Celsius threshold. So it's kind of an important mile marker, if you will, in our planet's kind of continual march towards warmer temperatures. Let's actually take a look at this from the standpoint of the global map, and this just kind of gives you a snapshot of what our planet is looking like right now. You can see that there is just lots of red on this map, and it turns out that the November numbers have just come in, and November is again just setting all kinds of records for heat. So between discussions in Paris, between 2015 being the hottest year on record, and the fact that we've also got a very strong El Nino cranking up in the Pacific, there's really lots to talk about. And so I want to introduce this amazing panel that we have. So we've got Joellen Russell, who's part of the Socom team. Joellen is at the University of Arizona. If you can wave, Joellen. We've got Lynne Talley, oceanographer extraordinaire from the Scripps Institution of Oceanography. We've got Greg Brusseau, who's actually joining us live from Punta Arenas in Chile. And Greg is normally in Seattle at the University of Washington. We've also got Veronica Tamsitt, who's also at the Scripps Institution of Oceanography. And Veronica actually just came from Australia, and she is about to head down to Punta Arenas because she's going to be on the ship, and she's going to tell us a lot more about what that's like. And then we have Isa Rosso, another Scripps graduate student, and Isa's also been down to the southern...
Postdoc.
It's okay. And she is going to be telling us about what it's like to work down in this incredible place. And then finally, we have a 7th grade teacher from the Princeton Day School, Ron Bannis, who's been doing some great stuff around oceanography with his class. So we've just got an amazing lineup of folks, and there's tons of stuff to cover. And I think really from the standpoint of folks who've been able to join us, just know that you can send your questions through Twitter. Just use the hashtag Socom Hangout. You can also use, I think, the Google interface to send any questions. And we are going to take questions at the end. So please think about any questions you'd like to ask these guys, because they're just an incredible group to have. Okay, so on that note, I want to just actually show everyone a picture of the Southern Ocean. So for those of you who aren't so familiar with the Southern Ocean, it stretches from 30 degrees south latitude down to Antarctica. And as we'll talk about over the next hour, the Southern Ocean does more than its fair share of the work in terms of absorbing carbon dioxide and heat from human activities like burning fossil fuels, the things that folks in Paris are talking about right now. So I want to bring you to the Southern Ocean and tell you more about this initiative that the folks on this Google Hangout are involved with today, and that's called the Socom Initiative. And Socom stands for Southern Ocean Carbon and Climate Observations and Modeling. And it's an incredibly innovative, multifaceted, multi-institutional project, and it's been essentially brought to life thanks to support from the National Science Foundation. So let's get started. And Joellen, I want to just talk to you and just to ask you, given everything that's being worked out, negotiated in Paris right now, how does that connect to the world's oceans, and how does that connect to the Southern Ocean in particular?
Well, the Southern Ocean actually takes up about half of the annual ocean uptake of carbon dioxide. So if you wanted to go measure where the ocean is taking up carbon, you'd go to the Southern Ocean. Now, we need the rest of the global ocean too, but the Southern Ocean is punching way above its weight class in terms of uptake. And it's not just the carbon, it's the heat too, which I think Lynne is going to talk about in a minute here. But the graphic that's up right now for you is basically there's the CO2 emissions on one axis, how much is gigatons of carbon per year, and the year is on the bottom. And what you'll notice is that while the U.S. is off their peak emissions by about 10% now, China has leaped into the lead. And so this conference of the parties, which is going on right now, so exciting, is actually has the potential to determine whether we bend that curve, whether not just the EU, not just the US, but all of the countries in the world help us to bend the curve and prevent some of the worst of what we're expecting are the global warming and ocean acidification effects of the increase in carbon in the atmosphere. So you want to pop to the next slide here. So when we emit all the carbon, what happens, this is just on the left-hand side, you're looking at all the amazing, sources of the excess anthropogenic human-made carbon in the atmosphere. And on the right-hand side, you're seeing where does it go. So about 44% stays in the atmosphere, 29% goes into the land, and 26% goes into the ocean. But what's interesting about this is the way that we calculate this is by measuring it really well in the atmosphere and measuring it in the ocean. And what we're contributing to this with this revolutionary new float program, biogeochemically censored floats in the Southern Ocean now, but of course this is, punching above its weight class, so this is where you start. Hopefully eventually we'll have a global array of this way to monitor it, is that you get the actual residual of what goes into the land from getting the ocean very well and the atmosphere very well. And we're poised to improve that plus or minus 1.8 gigatons of carbon, that plus or minus, we're going to reduce that uncertainty. And that's what's so exciting about this program. So next slide.
That's incredible.
The next one. So when you look at this amazing map of the uptake of human-made carbon dioxide in the ocean, what you notice is that there's the North Atlantic. This is done by Chris Sabine, who's the director at PMEL, the Pacific Marine Environmental Lab. He's a collaborator with us on this. And what you notice is this incredible, rich uptake of carbon dioxide all around Antarctica, down there in the southern part of the ocean. And this is what we propose to do better and better, is to actually observe that impact on as it takes it up and get it right, so that maybe eventually we could use our amazing atmospheric that are done by NOAA and other groups and the ocean measurements to actually get at treaty verification. So we need to get the ocean better so that we can get the world back on track, so that we can help bend that curve country by country. And it's so exciting. So one more plot just to make the point here. It's not just, the ocean's not just serving us by taking up carbon dioxide either. It's also serving by taking up heat, which you didn't think about very much if all you saw was a plot like this, where 2014 used to be the warmest year, now 2015 is far and away the warmest year. And part of the reason is that the ocean is temporarily giving up some of the heat that it had accumulated. And you can see that in this next plot, because we've got a massive El Nino going on in the Pacific, and here's the global sea surface temperature anomaly. So what we're saying is that the ocean is a huge reservoir for carbon and for heat. It's actually slowing the rate at which our atmosphere warms, both by helping soak up some of the CO2 and by actually taking up the heat as well. And this double whammy of extra oomph here, we need to quantify it. We need to narrow it down, because while the heat is what affects us on land, what we could have a potential treaty on is the carbon. We've got an agreement with China, the U.S. does now, but what they're doing at the Conference of the Parties right now in Paris right now is actually trying to get all the nations on Earth to make a commitment to reducing their emissions. And that is so exciting. So I think Lynne is going to, can we see the next slide? Lynne is going to talk about just how much of that amazing energy imbalance caused by the CO2 is actually being taken up by the ocean, because, she's one of the world's great oceanographers, I gotta say. It's such a privilege to work with her. So, Lynne.
Yeah, Lynne, tell us more.
Hi, hello everybody out there in the Hangout. Yeah, to follow up on what Joellen was just talking about, there's a lot of excess heat in the system, and it's manifested for us living in the atmosphere and on the land in surface temperature increases, and that's where we're seeing that high temperature now. But when we look down into the ocean, in this graphic, which is years along the bottom, so we're seeing from older to now, so 30 years, and along the axis, the graph is showing how much energy is in different parts of the climate system. So this is divided into the atmosphere, which is that tiny little purple thing at the bottom. That's what we live in. And then there's the land. That's a little brown thing, and some ice. And then most of the heat is sitting in the water, in the ocean. We have a lot of water out there, 70% of the planet. Water holds a lot more heat than air, and so what we're depositing sits there. And you can see it's split kind of evenly between the upper ocean. That would be sort of the upper, we would consider the 500 to 700 meters. That's about 2,000 feet of the ocean. That's the upper ocean. And then the rest of the ocean down to 6,000 meters or 20,000 feet is where the rest of the heat is. So we see most of it sitting there. And if we took all that heat and put it into the atmosphere where we live, we'd be 100 degrees warmer, which is kind of intolerable. There we would be on Venus. So we're very lucky to live on a water-covered planet, and that the water shields us from this excess warmth.
And Lynne, I have to ask,
there is a lot of heat in the ocean.
Does the ocean also kind of buy us time? Is that also what the ocean is doing? Is it like it's sort of storing that heat and preventing it from going into the atmosphere, like you just said? So from a time standpoint, what does that mean?
Yeah, well, it does in a sense, in kind of an abstract sense, because it's already there. It's already bought us the time, and we're on target for getting very warm with the ocean there. If we took the ocean away, we wouldn't be here. We wouldn't be living on this planet. We'd be living on Venus. Mm-hmm. The ocean, in absorbing CO2 from the atmosphere, buys time, but not as much as one would hope. And by storing the heat, there it is. A lot of the discussion about maybe global warming slowing in the last few years has actually been shown to just be an exchange of heat between the atmosphere and the ocean. You see the ocean's just sitting there with a lot of heat. There's no flattening in that curve at the very end towards 2010. Heat was going up. All of us oceanographers who study climate knew that there was no problem, no question about warming, even though a different amount was going in and out of that tiny little purple thing at the bottom. So you can imagine that's an exchange. We're living in an atmosphere whose temperature is sort of controlled by all of that heat in the ocean. And the heat in the ocean is coming in from the whole system, and it's due to the mostly to CO2 emissions, fossil fuel emissions. If we could look at the next slide, we can see a map of the ocean and how it's warming. These slides, actually, the one before and this one and the next one, come from the Intergovernmental Panel on Climate Change, which provides the scientific understanding for the climate conferences that are going on right now in Paris. So this map shows a lot of red, just like the map that Heidi showed. This one is the ocean itself, the upper ocean. The lot of red means it's warming. There's some regionality, there's some noise. Our measurements, of course, aren't perfect, but your overall picture is that the upper ocean is heating. And some parts heat more than others. For an oceanographer, that's super interesting, and for climate scientists, that's super interesting, because that understanding how that works helps us predict the climate better. So this is the upper ocean. We want to contrast that with the deep ocean on the next one. Next slide. We can see the next slide. There we go. This is a map. Oops, that's 2 slides. Back. Yay! There it is. On this slide from Sarah Perkey and Greg Johnson, This is also prominently featured in the IPCC Ocean chapter. We see the deep ocean is warming in the south, in the southern hemisphere. There's Antarctica, way far away from us. All that deep red is in the deep south, very far, far down there near Antarctica. There are parts of the deep ocean that may not be warming, but we do see a lot of heat going into the deep ocean in the south. That is a part of the ocean that is really far from where we live and from where our resources are deployed in the ocean. It's very undersampled, and what we'll see in the next slide is our problem with understanding how the Southern Ocean works. So we go to the next slide. We can't understand it. And so the Socom project, that's the one we're coming from, is out there with National Science Foundation funding and a lot of support also from NOAA and some from NASA to improve the way we observe that really important region. In the south around Antarctica is where the bottom waters go down. That's where that warming is. To understand the warming, we need to know all of the conditions around Antarctica. On this slide, you see all these colorful trajectories, colorful spaghetti. And the spaghetti ends as you get closer to Antarctica. Guess what? There's very little sampling down there. Why? Because there's ice in the winter. So mostly we sample there in the summer times from ships, and it's been pretty majorly undersampled. So with our program, we're extending the Argo, this float program, the profiling floats into that big void around Antarctica. And here's where we've already started. Last year, a cruise that I led, and that two people on here, Veronica and Isa, both participated in the cruise to deploy some of those white dots, the white dots that are just west of New Zealand, or east of New Zealand, flip around upside down, to the left in this map. So these are the dots, these are the floats we have out there now, and we're tracking every day. If you're really interested, you can get in there and get the data from them and plot them yourselves. I'm hoping the 7th grade class will be doing that. We'll be talking to later. And all the squiggly tracks are where the floats have traveled, even in the last year. Some of the floats are still under ice, and we're waiting with great enthusiasm for them to pop out and tell us everything that they've seen all winter. So this is the start of a wonderful data set. In addition to measuring temperature and salinity, these floats measure what we need for the carbon system in the Southern Ocean. And as Joellen said, that's super important for understanding climate. We put a lot of CO2 into the ocean. How does it get there? And we'll be understanding that. So the next slide shows where we're going. This is a little bit noisier. It has the same floats. They're in red, but the orange dots are the ones that we're putting out starting next week. Over there near Chile, it says Year 2 U.S. NB Palmer. That's actually 3 floats that we'll be talking to Greg and to Veronica about that project. Greg will be heading off to also get started with the floats in that say J.C. Ross on them. Isa will be going out into the Indian Ocean, etc. So we're starting to fill in. We'll be doing this for several more years. With that, we could talk about what is an orange dot? What's going into the ocean?
Yeah, that's
I think Greg will take us up there.
Segue to Greg. So I think Lynne, Joellen, you've both perfectly laid out the fact that okay, we know that the ocean plays a tremendously important role in our climate system, and then the Southern Ocean, this incredibly remote ocean. It may as well be Mars because it feels so far away and it's so difficult to work in. That it's this important mystery that needs to be unlocked, and it's so difficult to work there that these floats are really going to help us understand this body of water that it's playing such a crucial role. And that requires sending teams of scientists and engineers like Greg down there to get these floats deployed. So Greg, just tell us, what are you doing down in Punta Arenas, and how are these floats gonna do what we need them to do?
Yeah, so I'm down here in Punta Arenas to do the final checkout on those 3 floats that Lynne mentioned a minute ago. Essentially, once we put these instruments over the side of the ship, they're considered expendable and we never see them again. So we really want to make sure that everything is working perfectly before they go into the water. So we build them and test them over and over and over again in Seattle, and then ship them to wherever in the world the ship is going to be. And Seattle to Punta Arenas is quite a long ways, so any number of things could go wrong during that transport. So that's why I'm here, is to confirm that everything is working correctly, do a couple final calibrations, talk to Veronica and the ship's crew about deployment, make sure everyone's on the same page, and then I head out of here. So the slide that you're looking at kind of shows the anatomy of one of these instruments. This is sort of a generic depiction of one. But at the top of the instrument, you see that's where most of the instruments reside. It's also where the antenna resides, which is how we communicate the data that's collected back to us and all of the interested parties. And then all of the brains and batteries and everything reside in the float. But how they actually move up and down in the water is we use a buoyancy system. So density is what we use. Density is equal to mass over volume. Obviously, we can't change the mass of the float while it's in the water, but we can change its volume. So if you look at the very bottom of the picture, there's you see a bladder, and that's an external part of the float. So it kind of works the same way as like when you're in a swimming pool and you let all of the air out of your lungs, you essentially decrease your volume and you will sink in the pool. Vice versa, if you fill your lungs up, you'll rise back in the water and float more easily at the surface. So this works in the same way. While the float is underwater, if that bladder is completely empty, and then while it's at depth and we want to start coming back up, we push oil down into the bladder because oil is not compressible under that pressure. At 2,000 meters, there's a lot of pressure. So the oil fills up the bladder and the float rises to the surface. And then once it's right at the surface, we have an air pump on the inside of the float that takes air from the inside of the float and fills up the second part of the bladder, and that gives it the final push out of the water to get the antenna clear to transmit the data. So if you go to the next slide, I'll talk about a general profile. So the way these work are they are deployed from a ship at a specific point. They will descend down to 1,000 meters and drift there for 9 days. On the 10th day, it'll wake up and go down to 2,000 meters. Once it hits 2,000 meters, all of the sensors turn on and it starts sampling on its way back up to the surface. And then once it hits the surface, the antenna gets out of the water and it sits at the surface and just shouts to satellites for a little while and transmits all of the data. And then after that happens, the float will sink back down to 1,000 meters, drift for another 9 days, and then again on the 10th day it will start a profile again. Lynne mentioned that a handful of the floats are currently under the ice. So we do have some floats that are capable of living under the ice for as long as they need to. They run a certain algorithm that looks at temperature and salinity as they're reaching the surface, and the float determines whether there's ice above it or not. If it gets up to the top and it sees that there's ice, it will store the data and then go back to do another profile, and then when the ice is clear, it'll come up and just do this big data dump and shoot off everything that it learned while it was under the ice. So that's kind of the quick and simple explanation of how floats work.
That is pretty incredible, and it sounds to me like, okay, you're there, you're making sure that all of the floats are in the best possible shape, that they are ready to be deployed, and I guess basically then you're going to hand these floats off to Veronica, and Veronica, it's your job to actually deploy these floats.
Yeah, that's right. So I'll be leaving this afternoon, actually, to fly to Punta Arenas, where I'll meet up with Greg and get the floats. And then when we go out to sea on the ship, what I'll be doing is lowering the floats over the side of the ship. I think there's a slide showing that release. And then what we'll also do at the same time is use the ship's instruments to collect water samples, and I'll analyze those to try and compare what the float is measuring with the ship to improve how our instruments do.
And I think you're going to be blogging about it as well, is that right?
Yeah, so I'm going to be writing a blog about what it's like to be working in the Southern Ocean. As Lynne already mentioned, I was there before last year with Lynne and with Isa, and it's pretty extreme working down there. The weather is extreme, and it's also very isolated. But I will be able to post on the blog so you can hear all about what it's going to be like.
Okay, so you've been there before. You know what to expect. And actually, how long is the cruise going to last?
This one's a month, so not quite as long. Last year we were out for 7 weeks, and last year I spent Easter on this ship, and this year I'll be spending Christmas and New Year's on the same ship. So I've almost got all of my holidays spent in the Southern Ocean at this point.
Do you guys celebrate the holidays when you're out at sea like that?
Yeah,
Oh,
yeah.
yeah.
The cooks really put on a big feast, and you know, we put up decorations and stuff. We had an Easter egg hunt last time, so I'm sure we'll do something fun for Christmas.
No kidding. Wow, I would expect that hiding Easter eggs on a ship could be kind of complicated. I mean, especially if it's like rough seas, right? You gotta like tape them down or something.
Yeah, if you hide them in drawers and things, places they won't roll around, it's not too bad.
And I mean, just like from the standpoint, I mean, I've heard all of these stories now about how rough the seas can be. I mean, so are you like actually in like, are there bunk beds where like there's a bottom bunk and a top bunk? Like, what happens when you're trying to sleep and you've got, you know, seas kind of like the seas that we're seeing here?
I've never experienced the point where I felt like I was going to roll out of bed. Usually there's a boundary at the edge of the bunk, but sometimes it's hard to fall asleep when your head's moving back and forth on the pillow.
Oh my God. Yes. Well, I mean, Joellen, have you ever been out at sea where you kind of like had to lock yourself down into your bunk?
Absolutely. They have rails on the bunks, but if it really gets going, you can get bruised on those rails. So my favorite solution is to stuff life jackets, because there's a lot of those on board ship, underneath half of my mattress so that it kind of rolls me into the trough, and I, you know, sleep, you know, kind of snugged in there pretty hard. And then, of course, there's no bagging. No, it gets really rough.
Wow. Oh, my goodness. Well, you know, I think this is a perfect time, actually. You know, Isa, I'd love to just have you tell us a little bit more about what your experiences have been like being down in the Southern Ocean. You know, I said before that this is actually one of the most remote places on Earth. I mean, very few people actually get to go and see this. So when you were out, what did you see and what was it like?
Okay, so first of all, I think I feel very privileged to be part of that cruise and experience an ocean like that, because as you can see in this picture, this is pretty much the situation of the ocean every day. You know, the Southern Ocean is rough. You know, the waves are really strong, they're very high, and they smash against the boat continuously, right? And I think that you can study the Southern Ocean, you can read about the dynamics, you can understand what the role of the Southern Ocean is in the climate, but when you are there, there's really nothing that can prepare you for something like that. And so in this
right here now.
Yeah, so in this photo here, you can see basically a sequence of pictures that I've taken from the ice tower, which is basically the highest point of the boat. And you can see basically a wave smashing against the bow of the boat, and then the splash, because the wave is so energetic, the splash is coming right at the top of the ice tower, right against the windows of the ice tower. So, and that was, that was a lot of fun. I was there with Veronica and another student, and I think we had a really great time. I mean, I really love those rough seas, and I must say that talking with other people that have been there, previously, that was even, the roughest sea that they have experienced. So I cannot even imagine, how rough that can be. And I hope that because I'm going there again in January, I hope I will experience something like that too.
Yeah, video. We want to see it too. Bring home some video from the bridge.
Absolutely. But it's so dramatic. But as far south you go, so as closer you go to the Antarctic continent, you start seeing all these beautiful icebergs, right? So there are these huge buildings of ice, floating around, and they look so still, but they drift with the currents, right? And they are, in my personal opinion, they are really incredible. They are so beautiful. And I remember, like, one night I was at the bridge, and basically you have to look for the state of the ocean continuously, because you don't want to crash against anything, right? And there was the radar, and in the radar there was, like, there were, like, the images of the little icebergs that the radar was detecting, and we were completely surrounded. So the ship had to, move around accordingly to where the icebergs were going, because you don't want to crash against anything like that, right? And
Yeah,
so
we've all seen that Titanic, right?
yeah, exactly.
Oh, don't jinx it.
Knock on wood. And
I could point out that just a few weeks after we left that area, that started to freeze over again.
Oh,
And our floats that we put out
wow.
were under ice.
Wow. Well, and I mean, have you guys, like, do you get to see much wildlife? I mean, do you actually get to get off the ship at some point and spend some time, on the ice?
Well, it really depends on the type of cruise and the time of the year and the type and the ocean that you are going to sample. Like, I remember in previous cruises, I have seen a lot of wildlife, like whales and dolphins, and it was really beautiful. In that particular cruise, we actually been not that lucky. Like, we saw a lot of seabirds, and they are beautiful, but we didn't see any whales, or we weren't that far south to see penguins as well. So, and I guess that if you then can reach the Antarctic continent, then you can also go on land and explore and do other kind of research there. But I never left the ship, basically.
Yeah. Well, I have to ask you guys. So, Veronica, Isa, you're both starting out in your academic careers. I mean, when you were younger, did you ever imagine that you'd be traveling to the Southern Ocean? I mean, was this part of your long-term plan, or how did this happen?
No. Especially because, I come from Italy, so for me the ocean was just the Mediterranean Sea, right? So this kind of super, super warm and super, I never, when I was a kid, I actually never thought about the Southern Ocean. And I think that it just, so I've always been interested in the ocean and, understanding how the currents move, and looking at waves were just amazing. But so I started, my career as just a physicist. Excuse me. But then it was when I moved to Australia to do my PhD that I actually became more involved in the study of the Southern Ocean. And the more I was studying it, the more I was interested in really going out there and experience myself how it can be, to get measurement in an ocean like that, and what does it look like, right?
Wow.
And so,
Veronica?
Yeah, for me, I grew up in Australia, in Southeast Australia, so we're actually pretty close to the Southern Ocean. So most people don't get to see it growing up, and I guess I did a little bit. But I didn't really think I was going to study it that much, but I spent so much time rowing in boats on the water, and I guess it became a natural transition that I found another way to spend more time on boats.
On much bigger
We
boats.
used to row past a research ship in Seattle every day when I went to school there, and so that's what got me hooked on oceanography, I think.
Oh, no kidding. That's incredible. You know, we actually have a question that came in on Twitter from Lance, and the question is for Joellen, and the question is, Joellen, can you explain why specifically the Southern Ocean is so important to your line of work? What is it about the Southern Ocean?
Well, if for with the big CO2 changes in the atmosphere and the big warming that's coming, the Southern Ocean mixes more all the way to the bottom. So the picture that Lynne was showing you of the deep ocean warming, and it's warming most right around Antarctica. And it's not just warming right around Antarctica, it's also taking up CO2. So the bounce per ounce, if you wanted to go make measurements where you were going to see the change, the biggest change and the most of impact that the ocean can have, you'd go to the Southern Ocean, which is what is so amazing. So I live in Arizona now, in Tucson. I'm at the University of Arizona. Go Wildcats. Oh, do good on your exam today, guys. I know you're on. Woohoo. Sorry, intro oceanography. We have 800 students in intro oceanography this fall, and they're taking their exam today. So, yay. But it's so important to the climate here in Arizona because the heat uptake in the Southern Ocean is intense, and so is the carbon uptake. And it's because of the unique mixing that goes on there. We have these massive westerly winds that push the water away in the surface layer, away from Antarctica in all directions, which allows all this water to upwell from deep, deep, deep down to the surface and exchange along these density surfaces with the atmosphere. It's extraordinary, and it happens nowhere else on Earth like this. So we throw our people down there and our ships as much as we can, but given that a day of a ship might cost $40,000 a day bare boat, being able to add in these wonderful, everybody's frozen. I'm sorry, it froze for a second. Okay. Given that these floats cost roughly $75,000 or $85,000 a piece, and they'll do a profile every 5 or 10 days, somewhere in there, depending on what we're looking at, they'll do a profile every 5 to 10 days for the next 5 to 7 years. So these floats, while we need the ships to calibrate our floats, to get them deployed, and to make more detailed measurements, these decadal surveys that the Go Ship program does, that Lynne has been so integral to, we also need these floats to look at basically the daily, monthly, ongoing uptake of all this carbon and heat. It's so vital, and we've never been able to see the carbon implications, the nutrient implications. I mean, the Millennium Project estimates that roughly 70% of all the protein consumed in the third world by people is marine-based, is from the ocean, and the upwelling of not just the deep waters brings nutrients to the surface too. So that this is the Southern Ocean basically fertilizes, some enormous proportion, like 3/4 of all the global biological production in the ocean comes from the nutrients from the Southern Ocean. This place is absolutely extraordinary, and it's the most undersampled ocean. This is so intense and so exciting that we're getting to do this amazing float program.
Right. So clearly what happens in the Southern Ocean doesn't stay in the Southern Ocean. I mean, it makes its way all around the world's oceans, and can you
imagine how much hotter it would be in Phoenix and Tucson if it weren't taking up all this amazing heat and carbon? How much less food there'd be to eat for, so many people on planet Earth. It's so vital. Yeah. And we're in the process, it's not just, so this is an undersampled ocean. We don't get under the ice. We haven't been able to make all the biogeochemical measurements that we'd like. And what this does is allows us to check our models of what happens next. So this program is not just it's observations. It's also these huge climate models. And we work with the Geophysical Fluid Dynamics Laboratory at NOAA, and Jorge Sarmiento at Princeton, and Igor Kamenkovic at UMiami to improve our climate models by using these observations to test them, to make sure that we're doing the best we possibly can at shining a light on the path in front of us, this future climate change that we model with our models. So this is really important.
Well, and Joellen, you just said it, that this is such an important region. We have to understand what the future is going to look like. And Ron, I have to ask you, I mean, you're teaching 7th graders, and you've built this oceanography series, and you've been interacting with Veronica. I mean, you're potentially teaching the next generation of
Woohoo!
we need them. And so, could you tell us a little bit more about what your students will be learning?
Sure, sure. But before that, I just want to give a thanks to both you and Greta for inviting us onto this panel. Jack Madani, the other teacher, he had a scheduling conflict, but he would have loved to have been here. But what we do is we have a couple activities that involve oceanography, and one of the ones that we do is measure surface ocean currents. We do another one that does ocean temperature only in the surface, and this is going to add a totally different parameter to it, especially number one because of the depth of the data that we're going to be getting, as well as the location. You know, I did an informal poll with some of the students, and some of them knew what the Southern Ocean was, and some didn't. And there's quite a few entities here that are going to really be a good exposure for them, and hopefully it will spark more interest. You know, what Greg was talking about, the engineering of these floats kind of tapped into some of that interest in some of the other kids because they started Googling buoyancy engines. And we're going to see if we can do something like that, some activity around that, which was kind of interesting. I saw that you could actually do it with syringes and tubing. Yeah, there's a lot of information here, and I really appreciate being involved in it.
Wow. Well, I am so grateful that you and your class are really getting to know the Southern Ocean, because it is, as we've seen, so important. You know, I've got a follow-up question for anyone that would like to take it, and that is, what's the latest and greatest in terms of new research that's coming out of the Southern Ocean? I mean, have we learned anything surprising, you know, over the past couple of months that we should report out on?
Oh, well, we've learned. I'm actually working on. We're doing two things on the model side, and one is we've actually been looking at the seasonal structure of our mixed layer and our nutrient upwelling, et cetera. Now that we're actually able to get seasonal data, meaning we've had the pre-Socom floats that Lynne put out and Veronica and Isa put out last year are now reporting back all this amazing data. So we're actually doing several things. We're looking at how the mixed layer evolves, when and how the blooms of phytoplankton occur, and what the seasonality of this is, because it's one of the weaknesses in our really big climate models is that the seasonality is not quite right over the Southern Ocean, that we haven't quite got right the relationship between the big wind changes with the big mixed layer changes with the big upwelling and carbon and nutrient changes and then the bloom. So it's so exciting.
Wow, wow.
Yeah, I could chime in too. This is Lynne. Am I on?
Yes, you are.
Yay. One of the things we haven't mentioned is that Antarctica is an ice continent. It's covered with this amazing ice sheet. There's an enormous amount of water locked up in that ice. And the ice sheet is in a balance where it forms its glaciers. They move down to the ocean, and then they interact with the ocean and the water, and they break off. And what even in the last few months, there's been additional new very troubling findings of the increased rate that is happening. So as the Antarctic ice comes down and comes off, we're seeing melting, seeing some possible breakup of ice sheets. And there's a lot of new research going on, some new papers in the last few months showing that change in rates. And what's interesting to us as oceanographers with the observations we're making here is that the ocean is part of that balance. There are special places around Antarctica where warm water comes up close to the ice shelves, and so it's a factor in how fast they melt. So one of the things we'll contribute to with all of our new under ice and close into Antarctica measurements is understanding that melting. And that's super important for sea level. You take glaciers, melt them, put them in the water, that raises the sea level. not everywhere at the same rate. There's a lot of detail in that. But that is a climate change, global warming problem.
Absolutely.
So that's some new stuff.
And we're getting some fantastic new data that's pH related too. So we worry that as the atmosphere gets more and more CO2 in it, that CO2 dissolves into the ocean. Obviously, this is how we get this lovely carbon uptake. And what's bad about that, it's good for the rate of warming in the atmosphere, but it's bad because it causes acidification. Basically, the dissolved CO2 in the ocean forms a weak acid called carbonic acid, which actually we're titrating the ocean with all this human-made fossil fuel-related CO2, and we're actually monitoring the seasonal evolution of that. And I don't want to say we're discovering the seasonal evolution because it's not been seen in the actual acidification of the surface ocean around Antarctica. It's amazing. And how that actually gets injected deeper and what the impact it will have, essentially, we anticipate being able to we will see it over our program probably. It's occurred already seasonally once that we've observed, but the likelihood is we'll observe it during this program where we'll see another mass death of pteropods because of dissolution. So we're putting the floats out now. We expect that we may see this.
Well, Joellen, I have to ask you guys, so the topic of ocean acidification, I mean, I don't think it gets nearly the amount of coverage and discussion that it deserves. Joellen, what's your biggest fear with respect to ocean acidification?
Well, we're seeing really big changes in the circulation of the ocean in addition to the increase in CO2 in the atmosphere. So we worry that over time that it won't just be pteropods, which are little sea snails. It will also be coccolithophores and other carbonate-bearing, shell-forming organisms, and they form, of course, the base of the marine food web, the phytoplankton. But in addition to that, there are, international treasures like the Great Barrier Reef that eventually, given enough CO2, will dissolve as well. And so I tell my students, who are, 18 to 22, that they shouldn't wait. If they can scrape it together to get to the Great Barrier Reef or bring their kids, they should do it now. Because if we don't work on pulling down, bending that curve, pulling those emissions down, slowing the rate at which we emit all of this, that will happen soon. And we're going to see it in this program.
Yeah. Well, Ron, I have to ask you, when you guys are going to be working with Veronica, what will you guys be covering together jointly with your class and with Veronica? Will you be talking about ocean acidification, for example? What topics will you cover, and actually how will you interact with the floats?
Well, what we're going to try to do is, first I want to give them a little bit of a background of what acidification is and what some of the impact of it will have, and basically taking all the information that Veronica sends us via blog or how we download it or wherever we're going to get it off of the probes themselves. Well, I'm just kind of going to go with the flow and see where the interest lies and just explain each individual thing because, like I indicated, this is all brand new stuff for them. And it's almost like the proverbial kid in the candy store. There's a lot of stuff we can go over, and I want to hit the important points, of course, but wherever the interest lies, I'd be happy just to, keep on going anywhere with that as far as the kids are concerned. It's also, I'm sorry.
Discovery, woohoo!
That's what it is. That's what it's all about. And the plus about this program is that they'll be able to identify. It's not some obscure place that, when I was a kid, you'd look in a National Geographic magazine and say, oh, that's pretty cool, but you really didn't have a tie to it. And now with, with a blog and just being able to get a better, being able to just, get yourself into that spot, I think that'll help along with the interest and stimulate more.
All right.
Yeah, and as well as the blog, Ron's given me some decorations, so I'll be decorating the floats related to the students and taking photos and video of that so they can see that, it's like they've adopted that float, and then when they're tracking it, they actually have a bit more of a connection to where it is out there.
Yeah, we have to give a shout out to Princeton Day School there, yeah, of course.
That's fabulous. That's fabulous. Okay. Well, I should say, are there any other points that you feel like it would be important to share? Anything that we didn't cover that you feel like we should have mentioned? All right. Well, on that note, I think we'll be having one more Google Hangout, and I think that I'd love it if folks could check back in and we can report on all progress. And I also invite everyone to check out Veronica's blog. If you go to the Socom website, which is socom.princeton.edu, you'll find all kinds of information about both the Southern Ocean and about this specific program. And if there's any teachers who are teaching middle school students or high school students, also a great place to check out for resources. We got a ton of pictures. We'll have videos. It'll be just a nice way to hopefully bring the Southern Ocean to other classrooms. And maybe I'll just end with this question. So Lynne, you've been a real visionary and a legend in this field for many years now. And what are your hopes? What are your hopes for Socom? Like what do you think at the end of the day you really are hoping this program can accomplish?
I hope that because we received a significant amount of funding from NSF, we can really crystallize a whole new area of observing the oceans. Biogeochemistry is carbon and pH. We have a lot of optical sensors to look at the biology, and there's so much excitement about this from a lot of other countries and institutions and people we talk to everywhere. And one of our grand hopes is that this type of observing will become global. And so that's just a very, sort of a limited perspective. The bigger perspective is that we really fundamentally transform what we know about the Southern Ocean, how the climate works, what will happen with the Antarctic ice sheets, what will happen with all those organisms that live where the pH is going down. The Southern Ocean is one of the places to be hit hardest first from projections. We hope that our observations and the new modeling perspectives, Joellen is running the modeling part of this, and the idea is to improve our climate models, and we haven't really focused on that. Climate modeling is difficult because you're trying to put all the pieces together, the ocean, the atmosphere, the sun, the land, the plants, and everything, and run a model for many decades and thousands of years, which means you have to be pretty careful. And so the idea of this whole program is to improve that kind of climate modeling. With that, we can project the future better. With that, we understand where we're going better. I think actually we all understand where we're going now. We're going down the tubes in terms of the climate, and so action needs to be taken now. As scientists, we also want to make sure we have the best projections for the future, and we want the rest of the climate community to understand the role of the Southern Ocean. Every year, every 6 months, every 2 months, a paper comes out and says even more how important this region is.
Right.
So it's both a global vision, a local vision, and a vision for dealing with our problems of climate change.
Right. Well,
so we're really hoping that this conference of partners in Paris comes with to the right conclusions, right agreements.
We should all be following the conversations as they play out in Paris, because this will, what is decided over the next several days in Paris will have long-term implications for all of us. And actually, before I let you all go, I have to ask one more question that came over Twitter. And Greg, this is a question for you. What happens to the floats after they've done their job? Is there a retired float farm out there, or what happens?
Well, that's kind of the to use an old saying, you've got to break a few eggs to make an omelet, and unfortunately, they die in the batteries die in the water, and they tend to sink to the bottom of the ocean. So, Socom, while Socom is a relatively new program, the Argo float program, has been going on for over 10 years now. So there's a global array of floats, but mainly they look at temperature, salinity, and density. They're not as sophisticated as the floats that we're deploying in the Southern Ocean as of now. So when the project was first starting out, they were doing all kinds of environmental studies and impact assessments, and they came to the conclusion that a little bit of debris in the water was worth it to have this much data. And fortunately, over time, most of the metal will corrode away. So it is kind of a it does make me laugh a little bit, because while I do work in the environmental world, technically I do litter for a living. But
they become artificial reefs, if you will, as well. They
correct, yeah.
As reefs.
I believe it's for the greater good. So.
Well, thank you, and good luck. Safe travels back home. Veronica, safe travels down to Chile, and thanks to all of you for taking the time out to talk to us. And yeah, check out socom.princeton.edu for further updates, and we'll see you on the next Hangout. Thanks so much, everyone. Bye.
Thank you.
Thank you.